Aloha! Welcome to this lesson video for graphing quadratics in Vertex form. So we've already looked at graphing in standard form. So when we're given an equation, it's going to look a little different. When we have these parentheses, x minus some number or x plus some number squared, that's kind of the heads up that we're in vertex form as opposed to standard form. So with parentheses, we are vertex form. However, the same rule applies here. When A is positive, your graph opens up and you have a minimum point. When your A is negative, excuse me, your graph opens down, so you have a max point. So if you're following along with the note sheet, this is the column on the right. Here's our example. Does this quadratic open up or down? So remember, it depended on the A value. And here's our A. It's understood to be a -1. So because it's negative, that means our graph is opening down. And because it's opening down, so it looks something like this, it means that it has a max point. So we have a maximum. Okay, so some other things to know. How do you get the vertex from this point? Well, if you look and you notice, in the actual equation, there are h and k values. Just be careful, okay? It's minus h in the equation, but here, it's a positive h. So you want to think the opposite. Whatever you see in the parentheses, you take the opposite of that number, and that's your x value for your vertex. And then k, you take as it is. If it's plus k, it's positive. If it would have been minus a number, we would have had a negative number for our y. So with that said, let's look at this example. If I want to find the vertex, remember, there's no computation. I simply derive it from the equation. This tells me x, but I need to do the opposite. So I want a +3. And this tells me my y, but I take it as is, so a +2. So that's my vertex. My high point, my maximum will occur at 3, 2. Cool beans. All right, so other points that we need, like before, y-intercepts. And we know that the y-intercepts are points on the y-axis. So example, a point like that. And anytime that we move that point, the y value changes, but x does not. X is always 0. Okay, so we're going to use that to our advantage. So if I go back to this equation and I try to find the y-intercept, here's what I know. I know x is 0. So let me plug that in. Use that to my advantage. And let me plug in a 0 for my x. And so we've just got to follow order of operations, PEMDAS. Work inside the parentheses first. And so that's a -3, or actually you could even type this in your calculator, I suppose. But this would be a -3 that I'm going to square. A -3 squared would be a +9. And then I'm going to multiply by this -1 that's understood. I do that after the exponent. Exponents first, and then I multiply by this -1, which will make my 9 turn negative, plus a 2. So therefore my y will be a -7. Again, you could have just plugged this step in your calculator and it would have figured it out as long as you used the parentheses. Okay? So the axis of symmetry, remember when we have a U-shaped graph, it's kind of cool, it's symmetrical. So if this is my vertex, that's the halfway point, splitting the graph into 2 parts, and there's understood to be this line of reflection. And it's the same thing. Once we find the vertex, we just borrow that x number for the equation of the axis of symmetry. So if you recall before, the x value was 3 and the y value was 2 in the vertex. Therefore, my axis of symmetry, I'm just going to borrow that 3, and so I say x equals 3. All right, okie dokie. The x-intercepts are points on the x-axis, and I can move that point and the value of x changes. However, the value of y is always 0. It stays the same. So, let's see. I'm going to use that to my advantage again. I know that y is 0, so I need to find x. So let me plug 0 in for y, but it's kind of like standard form. Ooh, it doesn't look like that helps us out much, does it? Well, I've got to solve this for x, and in standard form, we factored or we did the quadratic formula. Not happening this time. Because we have these parentheses, we're actually doing that square root method. And so our objective is to get the parentheses squared by themselves. So I need to subtract 2 from both sides. So I would have, let's see, I would have negative 2 equals negative x minus 3 squared. But now remember, this negative, there's that 1 there. And these parentheses squared, it's like a jail. Remember, nothing can get in and nothing can get out. So if I can't distribute that negative 1 in, then how do I get rid of it? Well, if you're wanting to distribute, that means you're wanting to multiply. So the only other way to get rid of multiplication is to divide. Okay? So that's how we'll get rid of that negative sign. And over here, a negative divided by negative, that's just going to turn into a positive 2. Now that my parentheses are alone, I want to get rid of that square. We got to jailbreak the x minus 3. We got to free it, man. So we're going to take the square root. But because I took a square root, remember, plus or minus. And I'm going to have to come over here so I have a little bit more room. So I've got plus or minus square root of 2 equals x minus 3. Remember, we freed it. And the power and the root house cancel each other. So I'm just left with x minus 3. And to get x by itself, I've got to add 3. But even though it's kind of flip-flop from what we're used to, this plus or minus is still a protector. And when I add that 3, it has to go in front. There's no way it can get by that plus or minus sign. And so these would be my 2 points. I would say 3 plus radical 2 is a point, and 3 minus radical 2 with a y value of 0. These would be my 2 x-intercepts. Now you might not be sure what these numbers are, so if we type them in our calculator real quick, 3 plus 2 square root, it's roughly 1.41 and, whoops, sorry, I typed it in wrong. The first one is roughly 4.41, and when we do subtraction, we get roughly 1.59. So it's not very nice numbers, but at least on the number line, we'll know where to do our graph. Okay, so let me go and remember these are the 5 points that I want to see each time you graph. So we're going to do a rough sketch. My vertex, if you scroll back up, was positive 3, positive 2. So there's my vertex. My y-intercept was negative 7. So let me go down 1, 2, 3, 4, 5, 6, 7 and plot my y-intercept. Now remember, our quadratic is symmetric. So through this vertex, there's that axis of symmetry. So I can use that to my advantage, and I can take this point and I'm 3 away from the red line. So I can go reflect it 3 in the other direction. okay? And my new point would be 6, -7. And this guy was 0, -7. Okay? And then my two x-intercepts, they were kind of messy. They were 4.41, so 1, 2, 3, 4. So somewhere almost near half, 4.41, and 1.58. So roughly here. Okay? So then I can connect all those points. All right? And this was the 3 plus radical 2, 0. And this other green one was the 3 minus radical 2. Okay, so there's graphing our quadratics. I'll start another example. I might not get to finish with time. I'll try to go quick as I can, but I want to show you another one at least. This guy, because of this 2's positive, opens up, and that means he has a minimum. The vertex, remember, this is my x number, I just do the opposite, and this is my y number. So my vertex would be the point -1, 3. The y-intercept, I know that x is 0, so I use that to find the y value. And so 0 plus 1 is 1, so I'm really looking at 1 squared. I do the exponent first because of PEMDAS. 1 squared is 1. Then I times that by a 2. So I get 2 plus 3. So my y value is a 5. My axis of symmetry, I just steal from the vertex the x number. And that was -1. Then my x-intercept, here's where it's a little more work. I know that y is 0, so I have to use that square root method, okay? So I want to get my parentheses alone, so I want to subtract 3 first. So -3 equals 2x plus 1 squared. And I really kind of want to distribute that 2, but I can't because the parentheses squared's like a jail and nothing can get in, nothing can get out. So if I can't distribute, I have to divide. But ooh, I get this fraction over here. Doggone it. But at least I got my parentheses squared alone, so now I can take the square root of both the top and the bottom number. Okay, and so here's where we're at. I definitely have a plus or minus. Because that 3 is negative, I'm going to pull out an I. But I still have that square root of 2 at the bottom, which is no good. Bad news for the bears. So let me come over here where I have some more room. I would need to do that special fraction thing. So I would need to multiply square root of 2, square root of 2. So then that way, I will have plus or minus I radical 6 on the top, because we do 3 times 2 and get a 6. On the bottom, I have a pair of 2's now, so a 2 comes out. We've seen this fraction before. And then to get x by itself, I just simply subtract 1. But remember, plus or minus is a bodyguard, so -1 cannot get past it. Okay, so those are my two x-intercepts. -1 plus I radical 6 over 2. And -1 minus I radical 6 over 2. But notice there's something special about these numbers. There are i's in them. We had to pull out i's. So let's see how that affects us when we get a graph going. Our vertex was at -1, 3, if I remember correctly. -1, 3. Our y-intercept was at 0, what was it? 5. 1, 2, 3, 5. And so I'm going to have to rush. When I reflect it, I get -2, 5. But hang on a second. There are no x-intercepts because look, when I open, it opens up. Well, that's because we pulled out eyes. Because we had to pull out eyes, our graph will not cross the axis. But that's going to have to finish it for us on this video. Keep learning, guys, and I'll see you next time.